Robo Uno Plus is an open hardware development board inspired by the good old Arduino Uno R3. It was designed to be 100% compatible with the classic Uno R3 to use and expand the huge ecosystem around it, but redesigned from scratch with additional hardware features that make it a more comprehensive and versatile platform for enthusiasts and educators. The design of Robo Uno Plus grew from the feedback from 5 years of workshops we have given to educators and students, and 18 years of collective experience for personal projects by the team of Robo. It was specifically designed to help any new maker or educator have a smooth introduction to the world of electronics, programming, and Arduino, but at the same time boost the work of advanced and experienced people. You can add plug and play screen, and it also includes a port. You may add other components. The main components are a reset button, a USB-C port, and built-in buzzer, neopixels, four general purpose buttons, the ATmega 328 microcontroller, a JST SH port for plug-and-play modules, double header pins for more options. We have created codes for 20 projects, as you can see on the map here, and in this video we will take you through the first 10. Each file gets progressively more complex as features are used individually or in combination. Now that we're finished with the map, let's go ahead and start with the first one. Go to the GitHub webpage and find the code under RoboCY. The process is the same for all files, so let's go through the first one in detail. Copy and paste the code in Arduino IDE, in this case Hello World, and then find the correct port to ensure compatibility and the correct COM for the USB, as you can see here. This first file uses only the serial monitor. Under void setup, use serial begin 9600. Under void loop, include the counter ++, and in the serial print line, you can write whatever you want. In this case, hello world. Have a look at the serial monitor to see the result. In this case, hello world and counts. In the second program here, we're going to hear the buzzer. This obviously just uses the buzzer feature. Make sure you define the buzzer to the correct pin and frequency and duration. As we can see here, we use void loop, and you can also use tone delay as part of the programming. In the display, you can see how that works. Let's try it. That sounds about right. The third program is going to show us how to play the piano. Program the buttons to play the piano by defining the notes C, D, E, and F, and as before we use void loop. Define buttons to the appropriate pin and frequency to make sure we hit the correct note. Use void setup, button as an input and buzzer as an output. Let's try it. Those sound very good. In the next file, we're going to look at how we create traffic lights. Program the neopixels to the traffic light colors red, yellow, and green. Make sure you define time and color of neopixels in the right sequence as you would expect traffic lights to work. And then use void loop to run the codes. If everything is set up right, we're going to see an example of how that works in a couple of seconds. Here we go. The fifth file is going to show us how to create a police siren. Here we combine two of the features, neopixels and the buzzer, to get the police siren effect. Define the buzzer tone and the neopixel color, as shown here. Then make sure you use void loop to run the specific codes to create the siren effect. Let's try it. That sounds like a police siren. The next file is the binary counter. Here we combine all of the features, buttons, neopixel, and buzzers to create a binary counter. Make sure you define the buttons and use void loop to program them. Define the neopixel color, the buzzer tone, and each button. You may use void setup to make sure that the button is the input and the buzzer is the output, and also void loop to run the codes to make the binary counter. And here is the example. It works well. The seventh file is going to take us to Christmas, where we look at Christmas lights. Just as you would for your Christmas lights, each button is programmed to play a different combination of colors. So in this case, we use the buttons and neopixels for the programming. Make sure you define the pin and set up the color and time you want. Then you can use void loop to set up the 4 codes for the buttons in 4 different color combinations. You can see the code shown in the screen here in more detail. And in a minute, we're going to show you the example of how that works. All right, we're ready. Combination number 1. Combination number 2. You can see the different colors. Combination number 3. And here is the last one. The 8th code is the mood light. Here you can use the buttons to play with the brightness and the colors. The program shown here shows buttons A and C regulating brightness. A increases it and C decreases it. Buttons B and D change the color in opposite directions. Define the neopixel buzzer and button pins, and at void loop set up the buttons for brightness, remember A and C, and change color using B and D. Let's look at it in action now. As we've said already, if you press buttons A and C, you can increase and decrease the brightness, as you can see here, and buttons B and D can help you change the color, as you can see here. This definitely helps you set the mood. Enjoy. The 9th code in the series is the egg timer. Cook your egg soft, medium, and hard-boiled using a combination of features from Robo Uno Plus. program the time, and then using the buttons program it to the appropriate cooking time. Once it's ready, the buzzer will beep and the neopixels will turn on. Remember to define the buttons and buzzer to pins, and make sure you define the correct input and output. The buzzer is the output and the button is the input. Run your codes in void loop with predefined buttons and time. Have a look in the serial monitor for an example of when your egg is cooking. The last code we're going to see is the alarm. Here, you can use a 4-number code to disable the alarm. Use the wrong one and the buzzer goes off. If the sequence is incorrect, it activates the buzzer and lights the neopixels in red. If the sequence is correct, the buzzer beeps twice and the neopixel turns green. Entering an incorrect sequence 3 times in a row will activate the alarm. The sequence is defined by the expected sequence array. Define the buttons and buzzer to pins and define the neopixel color, and make sure you define the correct input and output. Run your codes in void loop with predefined buttons, buzzer, and neopixels. This is the third error in the code, and you can see that the red light is shining. Now I have entered the correct one, and you can see that it's a go. The alarm doesn't go off. Thanks for watching, and stay tuned for the next episode, which includes the next 10 codes.